In this video, we're going to do a number more codingbat examples where our whole goal is to practice this idea of booleans in. And I've just recreated the rules of booleans in here. Remember, these all apply to when I'm solving problems using booleans or using booleans in if statements. This last one actually only applies when I am doing a problem where I return a boolean, but these ones actually always apply. So let's go on to codingbat and let's do a bunch of different examples together. Unlike the last video, this video will contain a bunch of examples. I'm going to be moving fairly quickly, so if you need to pause me at any time just to catch up, that's totally fine. We're going to start with the one right next to sleep in, which is the one we did in the last video, called monkey trouble. Here we have two monkeys, monkey A and monkey B, and we have parameters called A smile and B smile, both of which are booleans. These two parameters tell me if each monkey is smiling. And when are we in trouble is when they are both smiling or neither one of them is smiling. And we're going to return true if we're in trouble. So since we're just getting started with this, I'm going to do this first in the longer way. I am going to jump into doing a cascading if statement, but I am going to kind of write out not quite the booleans end solution yet. So let's do this. When am I in trouble? Let's do if both of them are smiling. So how can I check if both of them are smiling? Well, A smile better be true, and B smile better be true. Then I can return true. What's the other way I'm in trouble? If neither of them are true. So let's do if A smile equals false, and B smile equals false. We're going to return true because we are in trouble. Else, we're going to return false. I realize I made this an if here. It doesn't actually matter since we're returning and return would end the method, but just for the sake of how we've been doing things, let's make this an else if. And if I hit go, this should work. All right, cool. Now, how can we make this better? Let me go back over to our rules of booleans in. Do we see this pattern anywhere? Yeah, I actually see A smile equals true and B smile equals true up here. So we know that I can just get rid of the equals true. So I can just do this as A smile and B smile and hit go, and that will work. Let's go back over here. Do I see equals false anywhere? Yeah, I see them in the next one. So I can change these to bang A smile and bang B smile. Remember the bang, the exclamation point, that means not. And this should still work. Now we saw this in sleep in, but I have this pattern of if something return true, else if something else return true, else return false. Aren't I returning the exact same thing in both of these parts of the if statement? Which means I should be able to combine these by using an or. When do I return true? If this is true, or if this other one is true. So let's do this and let's do or. And that should work. And now what does this look like? Well, if I go back to my rules of booleans in, don't I actually have this pattern here? If something return true, else return false. If something return true, else return false. So what can I do is just return all of this. And that will still work. Now, this is sort of the booleans in solution, but I do think there actually is kind of a separate clever solution here. If you think about it, when are we in trouble? If they're both smiling or if neither of them is smiling, doesn't that just mean that A smile and B smile would be the same? That's when we're in trouble. So I'm actually going to take this and replace it with A smile equals B smile. And this actually also works. So 2 different one-line solutions. I think this one's kind of the quote-unquote clever solution. The other one that we had is kind of the booleans in solution. And everything we had before that is also totally fine. I think this one and the last one we had are both actually pretty elegant. All right, let's go back into warm-up 1. And we're going to do the one called parrot trouble. It's actually right beneath monkey trouble. So here we go, parrot trouble. We have a loud talking parrot. So exciting. The hour parameter is the current hour time in the range from 0 to 23. And when are we in trouble is if the parrot is talking and the hour is before 7 or after 20. And we're returning true if we're in trouble. I'm going to try to booleans end this one right away. So let's do return if the parrot is talking, which this parameter tells us, so I think I can just say talking. Could I put equals equals true here? Yeah, I could, but do I have to? No. So I'm in trouble if the parrot's talking and the hour is before 7 or after 20. So isn't it hour is less than 7 or hour is greater than 20? And you can chain them together like this, but there is one problem here. And you'll see that if I hit go, I'm actually not going to pass all of the test cases here. Here's a new piece of information that I have to tell you. When you do complex math expressions, math follows a certain order of operations. If you've learned that in your math class as PEMDAS. Well, and or actually follow an order as well. And you might be wondering, well, which one happens first? And it's actually and that happens first, which means the first thing I'm going to do in this Boolean expression is do talking and hour is less than 7, which is actually not what I want. I kind of want these two to be evaluated together, right? Because the hour, or what I'm looking for in the hour, is kind of one check that I'm grouping together. Then I also want to check that the parrot is talking. So how can I change this is I just need parentheses around this expression so that it gets evaluated first. So parentheses work the same way that they do in math, that they do in Boolean expressions. So what have we learned here? And happens before or. And if you forget that, and also happens before or in the alphabet. So that's an easy way to remember it. Let's go back to warm-up 1, and let's go to the one called makes 10. It's in the last column here, just below the first one. Given two ints, a and b, we're going to return true if one of them is 10 or if their sum is 10. Let's booleans end this. I'm going to one-line it. Return if one of them is 10. So let's do a equals 10. Can I do or b equals 10? Or a plus b equals 10. And this works. I wanted to do this one to show you that you can chain together actually as many Boolean expressions as you want, and it should still work. Let's go back to warm-up 1. And let's do the one called near 100. It's in the first column, just a few below sleep in. All right, this one, given an int n, we're going to return true if it's within 10 of 100 or 200. And it has this kind of weird obscure note that we can maybe use math.abs to do this. Now, for this problem, we've actually never used math.abs before in this class. We've seen it and we've talked about it, but we've never used it. What does it actually do is absolute value. And why is that useful for checking if you're within a range of a certain number? Well, let's think about just checking if we're within 10 of 100. Isn't the issue with checking if you're within the range of a certain number that you could kind of be above that number or below that number? So what I would really want to do is something like return n minus 100 is less than or equal to 10, right? But the problem here is that what if n is 90? What if it's 80? Then this would still be true. So I actually have to check extra things to make sure it's also greater than 0. And this is only for the case where it's above 100. If it's below 100, I have to do more checks for that. So it actually just ends up being a lot of extra logic that you can replace by using math.abs. So I'm going to do this. Math.abs n minus 100 is less than or equal to 10. And let's think about that for a second. Math.abs will take the absolute value. So if I do this, let's say n is 108. 108 minus 100 is just 8. I take absolute value, that is less than or equal to 10, so I'm good to go. What if it's 92? Well, 92 minus 100 is negative 8, but I take the absolute value, so that's 8, that is less than or equal to 10, I'm good to go. And the problem with what I had before was the idea of checking 80. If I do 80 in here, n is 80, then 80 minus 100 would be negative 20, which would be less than or equal to 10, except I'm doing absolute value, which would make this 20. So again, math.abs can be super useful for checking when you're in the range of a certain number. I do have to check the other one too. So let's do or math.abs n minus 200 is less than or equal to 10. And this should work. There we go. We're going to do just a few more. So let's go ahead and go back to warm up 1. And let's go to back to Java. Let's go to the section called logic 1. These ones are actually all Boolean puzzles. Let's first click on this top left one, the very first one called cigar party. And I'm going to let you read this one on your own because it's super weird. So go ahead and pause the video. All right, I'm assuming you've read it now. Hopefully you paused me and actually read through this. So we have this weird squirrel party, and the squirrels like to have cigars when they party. We have the number of cigars and if it's a weekend as parameters. So let's do this. Let's do if is weekend. Again, I could put equals equals true there, but I don't have to. If it's a weekend, when is my party successful? Well, I can return it's successful when my cigars are greater than or equal to 40. Else, if it's not a weekend, when is my party successful? Well, it's when I have between 40 and 60 cigars. Now, you really want to write something like this where you put 40 is less than or equal to cigars is less than or equal to 60. But actually, this won't work. In Java, you are not allowed to check what we call compound inequalities. So you do actually have to do it like this. 40 is less than or equal to cigars, and cigars is less than or equal to 60, and then that will work. So we are not allowed to type just a compound inequality to check it in Java. You do have to do it as two separate Boolean expressions that you and together. Okay, let's go back to logic 1, and let's do the one called squirrel play. It's over here. All right, we got squirrels in Palo Alto. This is Palo Alto because the person who made codingbat is actually a Stanford grad, so, Palo Alto. So when do my squirrels play? This is actually really similar to the last one. Let's check this. If is summer, then when do my squirrels get to play? Well, I'm going to return when the temperature is between 60 and 100. That upper bound gets pushed up. Remember, I can't do a compound inequality here, so I'm going to return 60 is less than or equal to temp, and temp is less than or equal to 100. Else, let's return 60 is less than or equal to temp, and temp is less than or equal to 90. And there we go. Now, you'll notice that the last two, I didn't actually fully Boolean Zen, which I actually could have if I had wanted to. Let me show you what that would look like. So I could do it like this. If is summer and that, and I'm going to end up returning all this, or all of this. And I would actually argue that this, what I wrote here, is way less readable than what I had before. You could argue that other way too. I think that this is a bit of personal preference here, but I actually would probably write this the way that I had it earlier, which is like this. This would be my go-to instead of trying to one-line this, just because there's so many different things you're checking in this problem. All right, let's go back to logic 1, and let's do the one called sorta sum. It's right here. Given two ints a and b, we're going to return their sum. However, sums in the range from 10 to 19 are forbidden. Oh no. So in that case, we're just going to return 20. So let's do this. If a plus b, we want to check if it's in the range. So that's going to be some sort of inequality here, right? Is greater than or equal to 10, and a plus b is less than or equal to 20. Let's return 20. Technically, I could have put 19 here, but if it's 20, I'm going to return 20 anyways, so it doesn't really matter. Else, let's return a plus b. Cool. Now, notice that this one is actually a Boolean sort of question that does return an int. So there's no way here I could have done return a plus b is greater than or equal to 10, because that's actually just the wrong thing to do here. It's asking me not to return a Boolean, but to return an integer. Let's go back to logic 1. Let's do the one called teen sum, which is in the middle, kind of directly in the middle. All right, teen sum, similar to the last one. Given two ints, a and b, return their sum. However, teen values in the range 13 to 19 are extra lucky. So if either value is a teen, we're just going to return 19. So let's do this. If either value is a teen, so a is greater than or equal to 13 and a is less than or equal to 19, or b is greater than or equal to 13 and b is less than or equal to 19, we're going to return 19, else let's return a plus b. Remember, why was I able to chain this together without all these parentheses? Well, and happens before or. So I'm actually going to evaluate these together, which I want, evaluate these together, which I want, and then evaluate the whole thing together. All right, it's been a lot of me doing examples, so I'm going to leave this video here. What I would recommend from you is that you choose a number of these different codingbat puzzles to do on your own. In fact, in the description of this video, I've put a list of puzzles that you should try. Some of these, if you're in class with me, are going to be part of your homework. So I'm going to leave this video here. Hopefully you've been getting used to this idea of Boolean Zen and the sort of problem solving that goes along with it.